One-particle theory. Imagine for a moment that everything you see, everything you are, is built from a lie. Not a malicious lie, but a cosmic misunderstanding. You look at your hands, the device you're watching this on, the stars in the night sky, and you perceive a universe teeming with an uncountable number of particles. Trillions upon trillions of electrons, protons, and neutrons, all distinct, all following their own paths. But what if that perception is wrong? What if the vastness of existence, the sheer multiplicity of everything, is an illusion? What if, in reality, there is only one single particle playing every single role across all of space and all of time? This isn't the opening to a science fiction novel. This is a genuine, mind-altering hypothesis that sprang from the minds of some of the 20th century's most brilliant physicists. The story goes that in the 1940s, the eminent physicist John Archibald Wheeler picked up the phone and called his promising young colleague, Richard Feynman. Wheeler, known for his audacious and imaginative ideas, had been pondering a deep cosmic puzzle. Why are all electrons identical? Every single electron in the universe has the exact same mass, the exact same charge, the exact same spin. They are perfect, indistinguishable copies of one another. To a mind like Wheeler's, this wasn't a coincidence, it was a clue. He proposed a breathtakingly simple, yet utterly radical solution. He said to Feynman, "I know why all electrons have the same charge and the same mass, because they are all the same electron." This is the heart of the one-electron universe hypothesis. The idea is that the countless electrons we observe are not separate entities. Instead, they are all manifestations of a single, solitary electron that is weaving an unimaginatively complex path through space-time. To understand this, you have to throw out your linear, one-way concept of time. In this model, our single cosmic electron doesn't just move forward from the past to the future. It can also move backward in time. Imagine its path not as a straight line, but as an immense, tangled knot of string filling a four-dimensional box representing all of space-time. Now, if you were to slice through that box at one specific moment, what we call the present, you wouldn't see a single continuous string. You would see thousands, millions, billions of tiny dots where the string passes through your slice. Each dot would look like a separate, individual particle. But in reality, they are all just cross-sections of the same, single, time-traveling entity. This is where the theory gets even more elegant. Feynman had already been working with the idea that antimatter could be mathematically described as regular matter moving backward in time. A positron, the antimatter counterpart of an electron, has the same mass but an opposite positive charge. According to this framework, a positron is simply an electron traveling from the future to the past. So, in Wheeler's one-electron model, every time our cosmic particle's world line zigs forward in time, we perceive it as an electron. But when it zags and travels backward in time, we perceive it as a positron. The universe of particles we see is just this one entity's frantic dance between the Big Bang and the end of time. This single, unified world line would intersect our present moment over and over again. The electron in the hydrogen atom in a distant star, the electron that helps form the bonds in a water molecule on an undiscovered planet, and the electrons firing through the neural pathways of your brain as you process this very sentence, they are not cousins or siblings. They are, in the most literal sense, the very same object, just at different points in its incomprehensibly long and convoluted journey. This solves the identity problem perfectly. Of course, all electrons are identical because you are only ever measuring the same fundamental thing. It's like meeting the same person over and over again throughout your life, but because they are wearing a different hat each time, you believe you are meeting a crowd of different people. The universe isn't a crowd. It's a hall of mirrors reflecting a single, solitary actor. This idea redefines our place in the cosmos. You are not a collection of 7 octillion unique atoms. You are a temporary pattern, a fleeting intersection point of a single entity that is as old and as vast as time itself. The very atoms that make you are also making up everything else, everywhere else, at every other time. Your individuality, your very sense of being a distinct entity in a vast universe, begins to dissolve under the weight of this staggering proposition. We are left staring at a reality that is both infinitely simpler and infinitely stranger than we ever dared to imagine. Time's disturbing glitch. Accepting the one-electron universe as a possibility, even as a thought experiment, does more than just rearrange our cosmic furniture. It shatters the entire house. The consequences ripple outwards, disrupting our most fundamental assumptions about reality, starting with the very nature of time and causality. We experience life as a one-way street. The past is fixed, the future is unwritten, and cause always precedes effect. But if a single particle can travel backward in time, from the future to the past, then this entire structure collapses. This is the universe's most disturbing glitch. The effect can now exist before its cause. This concept is central to what's known as the Wheeler-Feynman absorber theory, a related and more developed idea that explores how particles interact across time. It suggests that an electron doesn't just radiate energy into the future, it also sends out an advanced wave that travels backward in time. This backward traveling wave gets a response from particles in the future, the absorbers, which then travels back to the present, perfectly canceling out any strange causality-violating effects. It's a complex, self-consistent loop where the future is, in a sense, collaborating with the past to create the present we experience. In this reality, the clear, linear arrow of time that governs our lives might be nothing more than a localized illusion, a product of our macroscopic perspective. At the quantum level, time isn't a river, it's a shimmering two-way superhighway. And this is where the implications become deeply personal and profoundly unsettling. If the future can influence the past, what does that mean for free will? Your choices, your decisions, feel like your own, unfolding in the present moment. But in a universe governed by these time-symmetric laws, your future actions might be part of the cosmic feedback loop that is creating the very moment you are now experiencing. Are you truly making a choice? Or are you simply playing out a role in a pre-existing four-dimensional pattern? Your life, your entire history from birth to death, might just be one small, intricate loop in the single particle's eternal world line. Your consciousness, your sense of self, becomes a flickering light, a moment of awareness that this cosmic particle experiences as it passes through your particular configuration in space-time. This is the ultimate erosion of identity. You are not a unique being. You are a state. Your existence is a temporary location visited by a single, timeless traveler. The very idea of you as a distinct entity is the glitch in perception. The universe isn't populated by billions of souls, it's animated by one. This leads to a chilling, almost solipsistic conclusion. Every person you've ever met, every historical figure you've read about, every living thing on this planet and beyond is, at its most fundamental level, you, just at a different point on the timeline. The joy, the suffering, the love, and the loss experienced by everyone throughout all of history are the experiences of this single entity. Now, before we get completely lost in this existential vortex, it's crucial to state that the one-electron universe is not a mainstream scientific theory today. It's largely considered a brilliant and insightful thought experiment. The most significant scientific objection is the overwhelming abundance of matter over antimatter in the observable universe. If the theory were true, the particle's world line would have to zag backward in time just as often as it zigs forward, meaning there should be a nearly equal number of electrons and positrons. We simply don't observe this. The cosmos is overwhelmingly made of matter, and this profound asymmetry remains one of physics' greatest unsolved mysteries. But the failure of this specific hypothesis doesn't diminish its power. It forced physicists to confront the deepest questions about time, identity, and the nature of particles. It opened doors to thinking about reality in ways that are non-intuitive and profoundly strange. So, while the universe is likely not inhabited by just one electron, the questions this theory raises are very much alive. It serves as a stark reminder that our perception of reality is filtered through the limitations of our biology and our classical intuition. The universe at its quantum core is under no obligation to make sense to us. It is wild, paradoxical, and beautiful. Perhaps our sense of individuality isn't a glitch, but perhaps it's not the entire story either. We are left to wonder, are we truly distinct actors on a cosmic stage, or are we all just masks worn by a single timeless performer? The answer is still out there, woven into the very fabric of space-time.